Hey guys, so it's often best laid plans with my videos where I decide I'm going to go out to a job where we've got something going on that I want to shoot a video on. And yeah, there's a lot going on that oddly, yeah, there's a lot going on that from an audio standpoint makes it hard to shoot these videos. We've got guys now that are doing the post tension on the cables, which is awesome, and I've shot some video of it. But while they're using the saw to cut all the big cables, makes it hard to do a video on the initial stages of framing, which is what I came to shoot this video on. So I'll be going through talking about some of the initial stages of framing that you see happening behind me with the walls going up, how things are attached to the foundation and all that. So I hope you guys enjoy this video. What you can see here is the crew that puts the tension on the cables have come around, dug out all what we call the live ends of the cables. Then they use the machine to put tension on them and then cut them off and patch them up. So I thought I would do a video on the initial stages of framing, which is really the exterior walls. They start with exterior walls and then everything else goes up based on when those exterior walls are completed. Interior walls, setting beams, things of that nature. But the first process is just putting up the walls, and I want to get into a little bit about how they do that, starting with what we call the bottom sill plate, S-I-L-L. So this is the piece of wood that is turned flat and is running all along the exterior. It's the exterior wall bottom of the house. We have to connect the framing to the house, and so I'm going to show you how the frame is connected and how we deal with things like moisture and air sealing. So the first thing the framers do is they lay out their walls. As you can see, all these red lines, they use a chalk and they lay out their entire wall. That's both interior and exterior. So I'm walking to a section of exterior wall that is not done yet to show you the methods that we use to anchor an exterior wall. When a foundation is being poured, all through the foundation, there are anchor bolts being set. I'm gonna turn it around to show you that. You see all these bolts through the foundation. These are anchored down in the concrete. They are kind of J-shaped so that when the concrete hardens, they can't be pulled out. We also use what we call straps. So throughout this house, we have a lot of these metal straps on the corners that, much like the bolts themselves, have a kind of a jade bottom to anchor them in, and then they are connected to the wood by nails or screws. Before even starting this, when we are submitting a building permit, we have certain requirements by cities, and that can vary by city. Some cities will require what they call a full framing, an engineered framing package. This city did not require that. And in my opinion, on a one-story home, that's probably overkill, especially as roof pitches are now coming down and we have less going on with wind-related issues and things like that because of the structure of the house. Well, that being said, the one thing the city did require is what's called a wind bracing plan done by an engineer. So a stamped plan of what we call wind bracing. So wind bracing will include certain cross framing members that help support the house for wind loads. Basically, this is lateral forces on the house. Think about a wind blowing sideways, hitting these big tall houses, and it's putting all of this load on the house, basically a big sail that's being pushed. So that's a combination of the way the framing's done along with some of the strapping. So, but at a minimum, we are putting the anchor bolts down. The framers, when they're building a wall, will drill holes where those anchor bolts are, and the bottom plate will slip right over top of those bolts. So let me show you. Here's an example of the anchor bolt. There is no washer or screw put on that yet, but they will go and put those on after All the exterior walls are done. And here's one of these straps. We'll have to get some more stuff in there to connect it to, but that is what is holding down the structure. Only the exterior walls are being strapped to the concrete. Interior walls are not. They're just sitting on the concrete themselves. We do, when we're talking about these initial walls, what we call the bottom plate is a different wood than all the studs are. It is a treated lumber meant to be able to deal with both, moisture and insects. So the treatment that they use often includes things like borate, which insects don't like, and also pressure treated lumber is able to deal with moisture, much better than regular lumber, which will absorb the moisture and can tend to rot. But to prevent even that, we do something, had a piece laying here at my feet, called a Sill seal. So this is a foam gasket that's laid down first, and the exterior bottom plate wall sits on top of this. What this does, this acts as a break between the moisture capillary issues you can have with concrete. Concrete absorbs moisture. So in a really rainy season, you could have a situation where the moisture content of the slab has increased to the point that it could cause issues with non-treated lumber. So first we use the treated lumber, and then we put this underneath it. So what we've got is a case where we have got this seal in between the bottom plate and the concrete. Prevents the moisture issue. It also works as a good air sealer, because even with all the weight on these walls and as flat as the slab may be, it's not perfectly flat. Neither is the wood for that matter. And so air can be pulled through with negative pressure, like you turn on an AC system and it wants to suck air into the house. This helps prevent air transfer. On top of that, we're also going through later and doing what we call poly seal, which is a low expanding closed cell foam along the bottom plates all through the home that prevents that air from being pulled through. So a lot of measures being taken for air sealing these days. Makes a huge difference with efficiency of homes, but also helps the bottom plates not deal with the moisture. Here's the roll of Sill seal, and here is where you can see that seal along the bottom plates. Another feature this house has, and it's to the point I think all new homes should have it, are 2x6 walls, 2x6 exterior walls. So, for so many years people wanted 2x6 walls because they said, well, it's so much more, it has so much more strength. And it does. I would say there's probably millions of 2x4 homes out there, especially we're still building homes 2x4. We get the plans from the architects. They drew 2x4 walls. Structurally, they are sound. We use an actual zip wall, which is a plywood, an OSB plywood on the outside. So these homes are completely sheathed in wood, which also locks it in and adds so much more structural stability than other things that some builders do. You'll see the production builders use these foam boards and things like that, and they are structural, but they are not going to have the structural integrity of a piece of, OSB sheathing that is nailed to all of these studs. But beyond strength, where I like the 2x6 walls is for insulation purposes. It allows us to get more insulation in the wall. And with energy codes becoming stricter and stricter all the time, this 2x6 wall gives us some leeway. Especially, we're able to now put spray foam in here up to 5.5 inches, because a 6-inch stud is actually 5.5 inches. Go figure. And that gives us a higher R rating in the walls. Also helps so much with plumbing. There are exterior walls where you will have plumbing in the walls. And the amount of times I've had a 2x4 wall where the plumbing doesn't quite fit in that wall is an issue. This prevents that from ever happening. So I highly recommend 2x6 walls. If you're having a floor plan designed, just have it designed with a 2x6 wall. Now, if you had a floor plan designed with a 2x4 wall, you can still do 2x6. Just know you're going to lose a little bit of interior space in the house. So 2x6 wall, way to go in my opinion. Now, when the framers are building these walls, they aren't actually laying down a piece of wood and then putting the vertical studs on top of all those. They actually build them laying flat on the ground. I'll put that up on the screen. They're in the middle of building a wall right now. So they build the wall laying flat, they build the bottom plate, the studs, and the top plate, and then they raise the wall. Once they raise it, they connect it to the other framing. So the top plate is just simply where the top of the wall is. You'll see this when you're looking at floor plans and may not understand what the architect is saying when they've got a plate height up there, but it's just the height that the wall stops. Then it becomes roof line with what we call rafters going up. So the taller a plate wall gets, the higher you can have a flat ceiling inside the interior room. So on a room like this, where it is kind of popping out and has, I think, 3 exterior walls, to get a flat ceiling, you can only have it flat at that plate height. That's probably a 10-foot plate, and so we probably have a 10-foot flat ceiling in there. I'm saying probably, because standing back here, I don't remember what it is, and I can't tell exactly. But you will see in some homes, especially when you get into lower price points, the plates will come down. The lower the outside plate is, the less brick you have, the less insulation you have. Basically, costs come down. But people still want a 10-foot ceiling inside that bedroom. Well, they will just slope up with the roof line till they get to 10, and then they'll go flat across. That's why with a lot of homes you'll walk into, especially bedrooms that are in the front of the home, you know, secondary bedrooms, things like that, you'll walk in and you'll see a lot of sloping up until it gets to 10 feet. That's because they might have had 8-foot plate walls, exterior walls going around it. This is that exterior wall with the bottom plate, the studs, and then a double top plate.